Okay, hello everyone. Thank you for joining us today. For today's presentation, we're going to, us here at Chromalox are going to have a walkthrough and kind of a discussion of the decarbonization efforts in the oil and gas world. We got a fair amount of examples and explanation of what we're seeing in the market. And who we have today to review and walk through this with us is Dean Strouser. He's our business development manager for oil and gas, has 32 years plus experience in the market, knows far more than I do, and he's always got interesting insight into the market and the applications that go with that. And with Dean, we also have Thomas Kibita, who's the sector sales engineer for oil and gas, and much like Dean, over 25 years experience in the same industry with the electric heating products that Chromalox has for everyone. And I learned a lot from both of these guys. They're both located in the Houston, Texas area and have lived and breathed this world for a long time. So with that, Dean, Thomas, I'm going to hand it off to you guys.
Okay, great. Appreciate that, Derek. If we could go to the next slide, please. Okay, so before we get started, let's begin with a brief history of Chromalox for those of you who are not familiar with our company. Chromalox was the first company to patent an electric resistance wire surrounded by an inner core with an outer metal sheath. So that patent was by Edwin Wiegand. Metal strip heaters were used to heat rail cars in the old days, as you can see to the right. And since this time, we graduated into making tubular elements. Also pictured are the tubular elements used for electric stove applications. And since we've been in business for over 104 years, we really would like for customers to leverage our experience to assist you with your electrification and decarbonization efforts. And also you can see here that we are owned by Aspirex Sarco based out of the UK since 2017, and we are still headquartered in Pittsburgh, Pennsylvania. Okay, so Chromalox offers, over the last 104 years, complete thermal management solutions for all types of applications with third-party in-house testing capabilities and certifications. So, we have our different product sectors, if you would. One is component technologies with cartridge heaters, tubular heaters, temperature control, flexible heaters, power controls that are used for the heaters, strip heaters, and also temperature sensors and other accessories. The component technologies you might find typically are used with end users, with OEM equipment like fryer machines for French fries, things of that nature. We also have our industrial heaters and systems division, which is a big part of Chromalox. This uses our tubular heater technology to make immersion heaters, circulation heaters, which are basically flange heaters inside of a ASME pipe body or non-ASME pipe body. Tank heating, heat transfer systems, we do package engineer systems, and then power control systems, air heaters for duct heating applications, and also electric steam generators. Then there's our heat trace products, self-regulating cable. We do MI cable for that, and also we offer all the controls and supervisory software that goes along with thermal management for heat trace systems. And then, of course, we do have our third-party and in-house testing capabilities. And Thomas, I wanted to ask you, with your 25-year industry experience, I mean, what stands out to you about Chromalox?
What stands out most to me, other than the wide breadth of all offerings you went through here really quickly, is our typically conservative approach in designing all of these products. And it's something that Chromalox will stand behind, and it pretty much always does exactly what it's intended to do for many years when all the right information is understood by everyone.
Very good, thank you. As far as our manufacturing footprint, you can see by the slide our different facilities. The ice and edge products are made in Ogden, Utah. And then we have, of course, our headquarters in Pittsburgh. We have a facility in Nuevo Laredo, Mexico, where we do some IH&S products and our component technologies. Laverne, Tennessee, we have our heat trace products are made and stocked there, as well as our power control panels for the heat trace and for the IH&S systems are made there as well. We have a facility in Soissons, France, and then of course heat trace facility in Wujiang, China. All right, so we're going to talk about, next slide please. We're going to talk about what is an electric resistance heating. Well, basically it's this is the core component of our technology. So it's an inner resistance wire, as you can see at the helical cord resistance wire. It's inserted into a tube and it's surrounded with magnesium oxide. Magnesium oxide is used because it has excellent dielectric strength. So, but it also has excellent thermal conductivity properties. So the key to the life of electric heater element is to have the electric resistance wire run as cool as possible at the inner core. If you get to high temperatures or you have magnesium oxide that is not compacted properly, it will ground out easily to the metal sheath tubing, as you see here. And with that metal sheath tubing, inside of there, we make our cold pin and termination. And this is the same technology we basically use for all of our tubular element applications. And then on the other side is we also offer medium voltage technology. And this is the same core concept as our low voltage, but we apply voltages from 1,000 volts up to 7,200 VAC without the use of a transformer. And that technology is called direct connect. So this is the difference between, on the left side, you see low voltage, on the right is medium voltage. So as of course, we go up the voltages for low voltage up to 1,000 volts, but that typically stops around 690 volts, as opposed to medium voltage is 1,000 to 7,200. The efficiencies for low voltage and medium voltage are a little bit different, but as we can tell here, both these electric resistance technologies are almost 100% efficient. So the big takeaway on the medium voltage that I'd like for everybody to have is the fact that using medium voltage reduces the amperage demand. And in the case here with the case study, you can see that on an example with the at 380 volt at 3,230 kW, at three phase, that's 4,900 amps. That's a total of 63 circuits that are going to be used if the customer wants to use 380 volt, as opposed to our direct connect technology at 6,600 volts. You're going to be drawing 280 amps, and that's only 3 circuits. So using medium voltage eliminates 60 circuits worth of wire, contactors, fusing, and installation labor. This is a huge savings when comparing low voltage to medium voltage. And typically the cutoff from a cost standpoint for medium voltage versus low voltage is you're probably around 1 megawatt. So that's where you need to take a serious look at going with the direct connect medium voltage technology from a cost saving standpoint. All right, next slide, please.
Actually, if I could interject 2 little things on that slide before we move on. When you look at those efficiencies, and since this is a webinar about decarbonization, you're not going to get anywhere close to these efficiencies and even the best fossil fuel fired heaters. You might be getting like 80% efficiency when it's brand new, not once it gets dirty, etc. And the other thing to remember is that 1 megawatt, we get into multi-megawatts. So don't just think electric's not a a viable option for, multi-megawatt, 10 million BTUs an hour type heaters and stuff. Dean's going to get into that more a little bit later. Thanks, Dean.
Yep. Thank you, Tom. All right. So what exactly is zero emission heat energy? Well, basically it's decarbonization, and decarbonization is the reduction in carbon intensity of worldwide energy to reduce global warming. There's two types of actually there's three types of CO2 emissions, but we're going to be concentrating on the two types, and this is Scope 1 and Scope 2. Scope 1 emissions is CO2 emissions located at the plant or the facility. Those are direct emissions through the production cycle at the individual plant and or production site. Scope 2 emissions, these are indirect emissions from the generation of third-party purchased supplied steam, heat, or cooling used at the manufacturing facilities. So in saying that, oil and gas companies are under pressure from investors, governments, and the public to create and implement ESG strategies, otherwise known as environmental, social, and governance. Chromalox is trying to impact the industry in small ways and big ways in order to assist customers with electrification and decarbonization. A lot of the environmental engineers, sustainability engineers, other type people are contacting Chromalox because they're really not sure how to decarbonize. Like Thomas was saying, getting away from fossil fuel heaters for large megawatt applications or large BTUs. So as far as, Chromalox, when we look at different systems, when evaluating the cost of large systems, it's important to consider the total ownership cost, and Chromalox can help you with this. It's just not the capital equipment cost we're looking at, and we'll talk about this more in depth at a later time. But these are other factors we need to look at that we hope the customers look at, and this is what we can do cost comparison for it with some of our calculator tools. If you decide to contact us or we contact you, you got to look at the 99. There's no flue stack losses. Our heaters are 99% efficient, like Thomas is alluding to. We have minimal maintenance, reduced heater footprint. We can also utilize low-cost electricity generated by renewable energy sources. That also takes away the Scope 2 as well. There are absolutely zero on-site emissions for electric heating. There's no need for emission control systems, and all gas-fired large heating systems require emission control systems. And there's absolutely no environmental permitting required for electric process heaters.
And something else that comes up every once in a while is you can put electric heaters in hazardous areas. They are certified to operate safely in hazardous areas, and we will manufacture them to meet those certifications. So you don't have to, for example, pipe all the way out, a couple of 100 feet away from where you need the heat because you have a fired heater, and then pipe it back, the product back, adding losses to the system, et cetera, and cost to the project.
Yes. So as we were saying previously, that it's important that when we look at trying to compare fossil fuels versus electric, that we really do a true analysis of the total operating cost. It's just not capital equipment versus capital equipment. So if we look at thermal conversion efficiencies, operational efficiencies, maintenance costs, production downtime, and then also the emission costs. There are customers out there that are subject to cap and trade and carbon taxes. So that's another cost that needs to be factored in as well. Thomas, you want to add anything regarding this as well?
Yeah, I'd like to say Chromalox in general, we have kind of an extra layer of customer support in the both in the MSSEs like myself and the BD guys like Dean. We can do a lot of uh, little work helping you guys out, you customers that going into getting a detailed quote, or just giving you the economic evaluation information you might need to determine what approach to go before you prepare your bid packages and all of that type of stuff. So we can support you from, you know, the first thought of it being even an option all the way through to project completion.
Great point. Thank you, Thomas. Yeah, okay, here's an example of a cap and trade carbon taxes for areas of the globe, really, that do have carbon taxes. So as you can see here, that gas-fired boilers or gas-fired equipment emit 465 tons of CO2 per 1 million BTU an hour per year. So that's quite a bit. So taking an example here, at $25 per ton of CO2, that's 11,625 million BTU an hour. So depending on which country or state you live within, the world electrification can have impactful financial results. So the other thing too is if your facility is already at the maximum CO2 emission, electric heat is a viable option if you do need some process heating at your facility or you need to expand. So that will actually allow you not to exceed your permits, which that can get very costly when you do actually have more emissions than you're supposed to. You're going to get fines and whatnot, but also it'll allow you to get your equipment and your plant going with electric heat will allow you to achieve your permitting a lot faster than if you wanted to use gas-fired. Okay, now we're going to talk about some of the applications for electric heaters that are used to replace, supplement, or decentralize from gas-fired heaters. So Chromalox is already using products to successfully decarbonize. We work with customers on an everyday basis who require reliability and robust designs for demanding applications. Such as the examples you see above here. And we're going to get into some of these applications later with exact examples where these heaters are being applied. These heaters are available with low voltage and medium voltage Chromalox products. And Chromalox heaters are used for processes that were previously considered only for fossil fuel fired equipment. Okay, so we'll get into some upstream applications here. As you can see, we'll start at the wellhead, which is on the left-hand side, and then we'll move into the production areas. Okay, one of the applications that is a great candidate for electric heaters is the heater treaters, and we have customers that are already changing or retrofitting equipment in the field now. They're replacing fire tubes with the electric immersion heaters. We can also provide indirect heating of the fire tube via heat transfer fluid, water glycol, or water. And you're looking at pressures less than 150 psig, temperatures less than 200. So the big point here is fire tubes can be retrofitted to add electric heaters.
And just to tag on to that, it's a really easy and quick swap out. Basically, unbolt the flange or the opening where the fire tube is inserted and put a bundle, or sometimes just put the bundle inside of the fire tube and seal up the exhaust if depending on the design and the duty.
Another application is the glycol reboiler, or also known as the glycol dehydration unit. This removes water vapor from gas streams, prevents the formation of hydrates inside the gas, prevents corrosion in the pipelines, and also protects equipment downstream, further downstream that's processing the equipment. It protects processing equipment further downstream. It's also critical to have dehydrated gas is to meet pipeline and process specifications. A lot of times on these on tariffs, the poorer the quality of gas, the less money that the company is going to make because the quality is not as high. So as far as in this particular application on the next slide, here, okay, great. All right, sorry, I was having a little technical glitch on my side. We can actually retrofit the glycol reboilers as well. Many owners and operators will continue to add inefficient retrofits onto existing gas-fired heaters, which also adds to their greenhouse gas emissions. Owners might not know that the Chromalox electric heat technology is a viable alternative and requires minimal retrofitting of existing equipment, just like Thomas had spoke to about. If you electrify 2 million BTU an hour gas-fired reboiler, you can eliminate 930 tons of CO2 a year. Then also you could use the gas that you're using to as the source of fuel for the glycol heater. You can sell it instead of burn it. All right, another application we have here is for amine reboilers, amine regeneration units. These are also called gas sweetening units, acid gas removal. Amines absorb the H2S and the CO2 from the gases, again, protecting pipeline processes and the quality of the gas to the customer. The amines heated via reboiler releases the gases, but the amine has to be recovered. So when the amines recovered, that's where they require the reboilers, where electric heaters can be used. Amine reboilers and processes that utilize amine are excellent candidates for electric process heating. As we see here, again, a lot of the owners and operators, when they think of reboiling applications, they think of gas-fired heaters. And when they think of gas-fired, it's going to add to their greenhouse gas emissions. So definitely Chromalox electric heaters are a viable solution for either directly heating amine process or indirectly heating amine process using, and what I mean by indirectly heating, you can use electric steam generators or boilers and electric heat transfer systems as well. And like Thomas said earlier, you can locate the electric heaters in the hazardous location without any issues.
Something else to point out real quick before you move on, Dean, excuse me. Chromalox, we're not necessarily building amine units, glycol dehydrators, TEG units, etc., heater treaters, but we go back decades with our heaters being used in those types of systems by packagers and end users, etc., over the years. So we do have experience in a lot of these, but you won't see on our website, an electric version of a reboiler or a heater treater, etc., because we're just adding our expertise to the people with the process expertise building the bigger systems.
Yeah, Thomas, and that's a great point. Chromalox continues to be a trusted partner for over 100+ years, and providing cost-effective and reliable designs and rugged designs that we stand behind. These designs create sustainable zero-emission thermal management systems for companies to meet their ESG goals. In this particular industry here, you know, from the wellhead to the midstream sector, where they're actually taking the gas and the oil, and they're transporting it and gathering it, and they're treating it. So we're going to talk a little bit here about the midstream side of things now. One of the big things for the midstream sector is gas processing. So the gas processing, the natural gas liquids, there's quite a bit of natural gas fractionation. So once the NGL have been removed from the natural gas stream, they're broken down into base components. And within this fractionation, in these stages, you have to boil off the hydrocarbons within the distillation column. So these distillation columns all have reboilers. As you can see here, we call them deethanizers, depropanizers. I mean, basically, we're separating the ethane from the NGL, separating the propane, as well as the butanes. So in this case, we're boiling off the heavies to re-inject into the pipeline for further processing downstream. To the right is a list of all the NGL feedstocks. And electric heaters are definitely a viable alternative to gas-fired reboilers for NGL processes that require vaporization, either heating indirectly, directly. We do have a viable solution for you. Here we have an example here that on the right-hand side, this customer is using a gas-fired heater to heat up a heat transfer fluid. That heat transfer fluid, which is piped over to the skeleton tube reboiler, which is at the base of the distillation column. If you notice, the gas-fired heater is located outside of a hazardous area, so you have to incur, you know, additional piping costs. You know, electric heaters are used to decentralize from existing API gas-fired heating systems. In this case, instead of running all that piping, you can actually have an electric heater right at the base of the distillation column without having, again, the hot oil heater off to the side or operating several different reboiler columns. We provide, that's called point of use electric heating. We can also, existing reboilers can be retrofitted considered to be retrofitted for an electric heater. We could also supply supplemental heat in case your processes are changing and you require more heat. Well, instead of bumping up to or increasing the size of your existing hot oil heaters with a retrofit or an additional hot oil heater, which will increase your emissions and require you have to get permitting, then electric should be considered to supplement that heat with a zero emission alternative. Generally speaking, we have low pressures of less than 300 psig, temperature ranges from 250 to 300. And the other alternative here too is to use a steam generator, electric steam generator versus a gas-fired steam generator. Or if you want to electrify the situation as well, just get rid of remove the gas-fired unit and go with a steam, electric steam solution.
And electric heaters, with SCR thyristor control, afford you, 90% turn down in most flow conditions, and you only need to put the heat input you need at the time. You don't have to have a 5 million BTU burner running if you only really need 1 million BTU or 500,000 for the moment. The electric heater can do 0 to 100% modulation of heat output into the process.
That's exactly right, Thomas. And you know what's interesting, a lot of what we've been talking about are for larger applications, right? You know, you're talking about a gas-fired hot oil heater or a gas-fired reboiler, glycol regen unit. You know, that could get into the higher BTUs. You know, we're targeting anything, you know, around 10 megawatt and lower. That's where we feel like Chromalox has a definite advantage. Doesn't mean we can't look at higher KWs as well, but 10 megawatt and lower seems to be a good spot for electric heaters from a sizing standpoint and cost standpoint. But again, we can increase up to larger sizes as well. So again, we were talking about, you know, large BTU applications. Well, you know, there's also a way to decarbonize with small by making small impacts. And one of the small impacts is with tank heating. Chromalox has an excellent product offering for tank heating. You know, all facilities require some type of storage for liquids and gases, which require thermal temperature management when being transported and stored. These are great applications to decarbonize and make small impacts. If you own or operate several facilities, the small impacts can add up when talking about greenhouse gas emission reductions. So decentralizing from larger fossil fuel fired heaters to point of use tank heating or pipe heating will be more efficient and save costs while reducing greenhouse gas emissions. So you can see here all the different types of tank heaters that we do offer. And also we offer our heat trace solutions for pipe maintenance and tank maintenance temperatures. Up to the right, it shows an API 560 hot oil heater that is used to heat up several different storage tanks. In this case, if the customer it has a tank battery of say 10 tanks, but they're only using 5 of those tanks out of that battery to store product, then they're using the BTUs on this heater to its 100% capacity just for 5 tanks. With electric heating, you can have point of use heating and that will definitely reduce your energy consumption from a cost standpoint, but you will also not be emitting all that CO2 for the process. And that's actually, depending on where you are, that could be pretty costly for that. So there's some really good efficiency values in electric point of use tank heating.
And also working with the market specialists like Dean or myself, we're gonna work with the best solution for your particular application, whether it's, you know, like you mentioned, our various facilities, whether it's some small heaters from Mexico or heat tracing from Tennessee, large heaters from Utah, or whatever the best combination of all the above is to get you the heat you need and the tanks you need.
Yep. Whether you are heating tanks directly or indirectly, we do have a solution. In this particular case, this is a cell and tube bundle that gets directly, you know, immersed into the storage tank. So we could flow heat transfer fluid from there, or steam through those tubes if you have an existing. So the point is that you can decentralize from or supplement existing inefficient fuel-fired heaters with electric point-of-use heaters. And most, you know, a lot of these facilities, they're older, and they have older fossil fuel-fired terminal heaters, and they're not necessarily designed for efficiency, high efficiency. They were designed for function. So that might be something you could look at as well. Is if you do have an older gas-fired heating system, is definitely look at electric as an alternate. The Chromalox, we do offer pre-designed heat transfer systems for those companies looking to make small emission reductions in a short amount of time. As you can see here, these systems here, these are tank heating, but this is indirect tank heating through coils. So this is one of the many applications that we already have pre-designed product and with short turnaround times. Another small impact you can make is with the tank heating is with direct immersion. So decentralizing heating from larger sources of fossil fuel fired heaters, like we spoke about before, to electric heating can improve efficiency while making small decarb impacts that could add up to significant impacts if you're adding up and changing out to electric heaters over several facilities. This pictured here shows our different direct immersion heaters. Also, we have indirect immersion heaters with our LTFX designs, to where once the heater is inserted into the tank, if the heater were to have a problem, you do not have to remove the heater. You simply just remove the electric, shown on the left side, the electric coil element out. So the actual heater tubes stay within the process without having to drain the tank, and that's a big seller and option for our customers. You know, another small impact is our electric heat trace, and Thomas is going to talk a little bit more about how this particular slide is pertains to better control of heat trace.
Yeah, typically in like a freeze protection type scenario, heater, the whole multiple circuits, that you can have up to 72 circuits being switched off and on based on the ambient temperature to turn off or on all of that heat tracing. Well, one way to really save a lot of energy, and it's part of a bunch of initiatives in many states, is to simply just replace the power connection boxes with one of our DTS controllers. The DTS has control based in it, reads the temperature and switches the power, etc. And what that allows you to do is, if instead of switching all 72, if 50 of them are indoors in the shade, or outdoors in the sun, etc., it's going to switch each circuit off and on individually as needed, whether it could be, line sensing even, to maintain the temperature of the pipe, no matter what the ambient, temperature is. But this provides a lot of energy savings in a very simple, elegant solution, and allowing you to switch each circuit individually only by having a smarter power box for that circuit. And this is often part of a lot of rebate programs in many regions when you optimize your consumption. So something to keep in mind.
Okay, in summary, there are many oil and gas processes, transport and storage applications that require heat either directly or indirectly. Chromalox has zero emission heat energy electric solutions available today. Whether your application is large or small, Chromalox can help you. Yep, Derek, I think we're done with the presentation part. We're happy to take any questions that might have come in, or to talk about any of the slides in detail, or retrofitting, or replacing, retrofitting, or supplementing gas-fired heating with the electric heaters.
Okay, excellent. Thanks, Dean. Thanks, Thomas. Yeah, I have. There's a couple questions I got sent in, so yeah, probably more discussion points, at least the way the questions are worded. So several times mentioned throughout the presentation, you mentioned hazardous areas. Can you clarify? I mean, is that class, division? When you say hazardous, can you define that?
Sure, we can build heaters for class 1, div 1 areas, controls as well, provided the duty's small enough for the control panels, because we're limited from an enclosure standpoint, but we could wire the controls part of it in a safe area to a heater in a hazardous area. And then the class 1 div 2 is very, very common for us as far as heaters and controls. And we do have all the third-party certifications behind all of that stuff.
So there really isn't a limitation out there electrically.
Not really. I mean, 5 megawatt heater in a class 1 div 1 area. Yeah, we probably can't do that control panel, but the rest of, for far and wide applications, definitely.
Nice. And also, Thomas, you mentioned earlier, and Dean a few times too, about the efficiency of electric heaters, and obviously the purpose of this presentation is retrofitting, we'll say, gas-fired systems and decarbonization efforts. The question basically reads, the efficiency of the electric heater as such being so efficient, is that factored into the retrofit design? Like, how does that impact it? Is it different? Is it a one-to-one?
No, you end up saving. Go ahead, Dean.
Well, I was just going to point out, and I'm sure Thomas, you can please add on. A lot of these gas-fired heating systems, because of some of their inherent inefficiencies, especially the older units, they're sometimes oversized. Okay, so the fact that when we go to look at if you're looking at retrofitting or changing out, then we want to look at your process conditions as well, because at times we've seen where the customers might give us the information on their gas-fired heating equipment, and then we come back and we see the size of it, and we run our calculations, and it's not based on absorbed heat. So electric heaters are sized based on absorbed heat with some safety factor designed in them as well. But basically, electric resistive heaters, whatever power you're getting you put into it, is because it's a constant resistance wire, and due to Ohm's law, whatever power you're getting into it, voltage power you're providing it, is you're going to get the kW out, the same amount of kW based on Ohm's law. So I think, Thomas, you had maybe more to offer.
No, it's just the main thing is you can often get by with a smaller electric heater because of all those things you mentioned. So, if it ended up being a megawatt fired heater, you might only need 800 kilowatts of electric heater. So your meter's not going to spin as fast as your electric meter won't spin as fast as your gas meter.
So you kind of just want to consider the thermal input of the application, not necessarily the burner that's installed.
Right. We want to look at
That's exactly right.
What the process is. We don't want to quote a heater just to replace a certain duty fired heater, electric heater to replace a fired heater. We rather look at the process, do the calculations as far as what the heat duty should be to get the input into the process fluids.
Well, and that kind of segues into the next question. You mentioned calculator tools and detailed quotes. I believe Thomas did earlier as well, if I remember right. In those calculator tools, that would include scope 1, scope 2, as you mentioned previously, and equipment costs, not the heater, but we'll say the ancillary products to run the heater. I mean, can that be considered, and who to contact? And I guess that's pretty obvious from the screen.
Yeah, you could contact your local sales support. They know how to get a hold of us and or us directly. And yes, we have lots of tools in development, and we'd love to get feedback on all of them for almost any project you might have to compare the numbers, because it's a fast-paced evolution going on right now. Reducing all of these emissions, and there's a lot of factors at play, as you were alluding to, with the not just what the cost of the equipment is, what the cost of the permitting is, and then there's also a whole lot of other maintenance stuff as well as installation. Whereas if you had to replace a fired heater anyway, you might have a lot less installation and get some landscape, some space back, because typically electric heaters are smaller physically than fired heaters. Um, and that might give you, space for other things you need in your facility.
That's a good point, Thomas. I mean, and you know as well as I do, I've seen that it go as a factor of almost a fourth of the footprint of gas-fired units in some cases.
Yeah, that was one of my favorite site visits. I won't say where, but there was people objecting to getting rid of fired boilers, putting in electric boilers. It was a oil refinery type facility, and they were saying they only had a little slab for us to put the electric boiler. And when we walked out to look at it, we were saying, yeah, we can make it fit there. And then we're like, oh, by the way, both of your fired boilers are shut down. There was like 6 people shoveling soot out the bottom of it, and it was at least 6 times larger than what they were giving us space wise to put an electric boiler.
Oh, wow. Okay, very good. Time for one more question. It just came in, and this pertains to the state regulations. Do we have a list of states or regions that are taking part in state or federal incentive programs for the DTS controllers? Actually, and obviously Thomas and Dean, you can answer too, but I know of 3 states that are. So I mean, the answer is yes. I know here in Colorado, that's definitely one, and then 2 in the western states as well. Honestly, that website that's on the slide points you, and there's, gosh, I don't remember when we looked at it, Thomas. There's anywhere from 50 to 100 different incentives in each state. Not all of them pertaining to, say, electric heat, but they're all decarbonization efforts, and then the rebates and stuff you have to either apply for or qualify for. But I can tell you, at least on my end, I helped, write one in my area, and I'm sure Thomas, Dean, you guys have started to get a lot of that lately too, with our focus on decarbonization. I'll let you speak. Sorry. Thomas,
Derek. Yeah, Derek. My advice right now is to go to this site and to see if your state is offering these rebates. I mean, if that's something you want to contact your Chromalox representative, we'll be happy to do the research for you on that. But like you said, I mean, some states are doing it, some states aren't. So the other side of it is that if you're looking at, while you're looking at this particular type of application, maybe there's some other type of applications for other gas-fired units, within your facility. Again, this is small impacts, but they do add up to larger impacts. So, one of the things that we do get is, we get the facility people calling us, asking us, how am I gonna, I'm told I have to decarb. I need to electrify, and I don't know where to start. Well, this is a place to start with the small impact side of it. And of course, we call it a thermal audit. So we're happy to help you out with your thermal audit, if you would. So,
in case anybody couldn't read that slide, just go to energy.gov, and then there's a list of initiatives, and then the EERE, the committees and all of that type of stuff, talking about the efficiencies, and all of that kind of stuff. And that's a good launch site to get into all of the other programs.
excellent. And what was that site again, Thomas?
Energy.gov is a good starting point.
That's an easy one to remember. Okay. Great. Well, we thank everybody for attending. We're kind of getting to the end of the hour. So, Dean, Thomas, great job as usual, and really appreciate you walking through that with us. For everyone else on the call, our contact information is right there. You're welcome to reach out with any other questions or thoughts after the presentation. It'll be available for everyone on our YouTube site if you need to go back and review it. And yeah, again, Dean Thomas, great job. And I will let everyone go.
Thanks for hosting, Derek. Thanks, everybody.
Yeah, thanks for hosting, Derek. Yeah, thanks for attending, everybody. Have a great day. Bye-bye.